Very good morning, students. For this lecturing video session, I am going to solve one more problem from support reactions. So let me just read out the question here. Find the reaction at supports for the problem shown in figure. So this was a built-in support and with point load, and this is UVL, that is uniformly varying load, isn't it? Right. So you will be having confusion, right? Suppose let me just make it here. Let's clarify you. If the load is mentioned in this way, it is UDL. If the load is mentioned in this pattern, again it is UDL. So if the load is mentioned in this way, it is UVL. Suppose the load is mentioned in this pattern. If the load is, for an example, it is mentioned 10 kilonewton per meter, and here it is 5 kilonewton per meter. What exactly it is? So the reason why I'm just make you to understand here is such problem can be asked. So this is the combination of UDL and UEL. Look at here. So this is UVL and this is UDL. So this can be converted in this way. Right? This can be converted into this manner. Right? You'll have to be very careful when such problem being asked. So you'll have to just convert first that into UVL and next that is into UDL. So UDL can be also mentioned in this pattern also, right? So you have to be very careful in such a cases, right? So let me just convert this one. So up to here it is total, it is 10, isn't it? Total up to here it is 10, and here up to here it is 5. So this could be of 5 kilonewton per meter, and the balance is 5 kilonewton per meter. Got it? So don't get confused while the problem says such kind of figure. So that needs to be, that's a combination of UDL and UEL. So the total intensity would have been given here. Then you'll have to minus this value. 10 minus 5, you'll get 5. And up to here it is 5. So that's it is 5. Right? So which is irrelevant to this problem, but I just for your knowledge sake, I'm just clarifying here. Right? So first thing is, so to draw the FBD, this UVL needs to be converted into point load, that is PL, isn't it? So UVL to be converted into PL. So PL formula is equal to half into load intensity into the length, that is a span length. So half into W, which is the load intensity of the UVL, which is 6, into the length of the UVL, which is 3 meter. So if we just calculate is 3 into 3, which is 9 kilonewton. And the load acting point is equal to 1 by 3 into L from the maximum side, from maximum load side, right? That is equal to 1 by 3 into length of the UEL is 3 meter, which is equal to 1 meter. Got it? So let me just draw the FBD here now. To start with the FBD, so look at here, this is the fixed support, right? So the fixed support will have 3 reactions. The first one is vertical reaction, the horizontal reaction, and a moment, right? So let me just take this as A, and this will have the vertical reaction and horizontal reaction and moment in anticlockwise direction, MA. Right. Let me just extend this beam up to C, where point load is of magnitude 6 kilonewton is acting, and between here it is P. Right. So this UVL has been converted into point load of magnitude 9 kilonewton, where it is acting 1 meter from the maximum side. So in total it is in this way, right? So up to here it is 3 meter, and from here to here it is 3 meter. So now look at here, it's 1 meter from the maximum side. Maximum side is at B. So from here it is 1 meter. So the load which is acting here, that is 1 meter. Got it? So then balance could be of 2 meters. So total from A to B is 3 meters. So the left out is 2 meters, isn't it? So the magnitude is 9 kilonewton. Don't forget to put 6 kilonewton per meter. So look at the unit, which is in kilonewton per meter. So what is the point load, the unit of point load, which should be in Newton or kilonewton, right? So that has been arrived here. So that you'll have to implement here in while you just even drawing the FBD, right? So now I'm going to apply the equilibrium conditions. Applying equilibrium condition. What are they? Conditions. Summation H is equal to 0, summation V equal to 0, and sum of moment equal to 0. Let me just consider summation H equal to 0 first. The horizontal. So the quadrant, let me just draw it here. This would be a vertical is positive, this right towards right is positive, towards down is negative, towards left is negative, isn't it? So just remember this. The reason why I'm just drawing it, so you should not get confused, right? In the exam point of view, you just draw it in a pencil and then later you just erase this off, right? So this is what you are understanding when I'm just mentioning here. So 0 equal to the horizontal forces. Look at here, HA, which is here, right? Which is acting in the positive X direction, so it's a positive. Any other horizontal force is there? No. So the HA equal to 0. Got it? Next, I am going to resolve the vertical forces. Vertical forces. Summation V equal to 0. 0 equal to vertical forces. Look at here at point A, a vertical force which is acting vertically upwards, which carries the positive sign. So VA. Let me just move to the next one where the 9 kilonewton which is acting vertically downwards, which will carry negative sign of minus 9. Then this 6 which is of the negative direction. This is traveling the negative y direction. So minus 6. So 0 is equal to VA minus 15. So therefore VA equal to 15 kilonewton. 15 kilonewton. Right. Next, I am going to take the moment. Taking the moment about point A. Right. We're going to take the moment about point A here. Right. So sum of moment A equal to 0. So 0 equal to, look at here at A, a moment is there which is acting in the negative, that is the anti-clockwise, which will carry negative sign. So MA. So in the origin there won't be any distance. So the HA and VA, that moment would be 0 because the product of force and its perpendicular distance is the moment, right? So HA into 0, 0, VA into 0, 0. Let me just move to this point where a force is acting of 9 kilonewton magnitude, right? Which is acting vertically downwards. It tends to rotate the object in clockwise direction, which will carry positive sign. So the force into its perpendicular distance from the origin, which is 2 meter. Got it? And look at here at C, a force which is acting vertically downwards. So definitely it will positive direction because it tends to rotate the object in the clockwise direction. So force into its perpendicular distance from the origin, from A to C, it is 3 plus 3, which is 6. Right? So 0 equal to minus MA plus 18 plus 6 into so total it is 3 plus 2, sorry, this is 2 meter, right? So you'll have to be very careful while drawing the FBD. So because you will be going to refer the FBD only. So if as long when the FBD is perfectly fine, then you won't go anywhere wrong. So this would be of 5, right? So 3 plus 2, which is 5. So 6 into 5, which is 30. So 0 is equal to minus MA plus 48. So let me just take this MA in the other side. So MA equal to 48. What would be the unit here? Kilonewton meter. Because it's a moment, right? Right. Fine. Next, you'll have to write the result here. So HA equal to 0, isn't it? HA is equal to 0. Then VA equal to 15 kilonewton, isn't it? And MA, there's a moment about A equal to 48 kilonewton meter. Right. Hope you have all understood how to solve when such kind of problem is asked. It's a combination of the supports, hinge support, and it's a fixed support, and the load pattern is UVL. So first you'll have to convert that UVL into point load, then you'll have to draw the FBD, then apply the equilibrium conditions, summation H is equal to 0, summation V is equal to 0, and summation M is equal to 0. Then you just try to solve one by one after the other, then you will find the unknown values. Thank you.